Now let's review back our measurement and see how we are going to learn about the metric conversions or metric prefixes. A prefix is actually a few letter words that are added before a base unit, and it will either increase or decrease that base unit. For example, a prefix of kilometer means it's 1,000. A kilo is a prefix for 1,000, and if you put that in front of a meter, it makes it 1,000 times larger. And if you place that in front of a gram, it makes it 1,000 times larger. So a prefix is a common prefix, K, that can be either put on the length, the mass, or even on liters. You can say kiloliters and it would still be, it's just not commonly used, but it's a value that can be added or it can be expressed. Similarly, we have lots of different prefixes that will decrease the size of the unit. So I'm going to highlight number, which ones you need to know. You need to know kilo. The prefix kilo, the symbol is small k. It means 1,000. The numerical value is 1,000 and it's expressed as 10 to the power 3. Then the prefix that decrease the size, I want you to sort of know these three: deci, centi, and milli. Deci we don't really use a lot, but it's good to know it as a concept. It's 1/10, or we can say this. Let me just raise that. It's actually 1/10. It's already written over here. And the centi is 100, and the milli is 1,000. And scientific notation would be 10 to minus 1, minus 2, minus 3. Respectively. So you must know these four, because these four prefixes will come use a lot in this class and other classes as well. And now these prefixes can be applied in front of either any of the base units or for the metric system, whether it's for mass, volume, or height. It can be applied to either one of them, and we can have different values for those prefixes. So for example, let's look at a value of mass, or sorry, of distance. So here we have a value of distance, and we have a prefix of centi in front of the word meter. Now centi means 100, so that's why you have in a meter you have 100 centimeters, and in a meters you have 1,000 millimeters. Now the relationship that is expressed over here, for example, 1 meter equals 100 centimeters, or a meter equals 1,000 millimeters, is called as an equality. So know this term, because often I'll ask you, what is the equality between these two values? For example, if we were to look at an equality between the ones that you're more familiar with, a foot has 12 inches. So the equality is that they're both the same. That's a relationship between two units. And in metric systems, because the prefix can be used to express the equality. So here are the main equalities that you would need to know for this class. A kilometer is 1,000 meters. A meter has 1,000 millimeters. A meter as 100 centimeters, and if I was to express a millimeters, then a millimeter is 1,000th of a meter. So pretty much we're using the prefixes either way to express them. Each of them is a quantity, and notice that all are based off tens. So I'm just going to go ahead and go through these slides, and I'm going to focus more on the problem solving than the actual equality, because you need to sort of memorize these, and I'm not really much sense of me reading it off the slides. Same thing, a kiloliters, a liter to a centiliter, and a milliliter to a liter. So again, that's the relationship that you should know. And here is the relationship in mass. Again, notice I've kept the same consistency for you to see that you can just change the prefix to express whichever equality you're looking for, whether you're looking for length, volume, or mass. So you need to know these equalities. So let's go on to the section that's more for me to teach you, is that there are sometimes equalities that are difference between the metric and the US conversions. So for example, a conversion of 1 pound to a kilogram would be an American metric conversion, because over here you have the metric conversion, in which you have a meter equals 1,000. And then here over here you have the American conversion. Both units are in the American units. And this last one is a metric American conversion, that is how many kilograms are equivalent to a pound. And there are tricks to it. You know, you don't need to know all of them that are present in your book or in the chart that I'll show you. You can actually, there's a chart over here, and you don't really have to know all of them. For example, if you know the difference, the equality between grams and pounds, then you can convert your pounds to your like ounces to pounds, and then convert them into grams to come to your kilograms. I hope, did I make sense to you, or did I go too fast? Let's say we have something in X ounces, and you have to convert that into kilograms, and you only know the relationship that I'm pointing over here. If that was the case, then you can convert your ounces to pound, which is sort of like your plan, your conversion plan. Your pound can then be converted to gram, because this is the equality that we now have, and the gram then can be converted to the kilogram. So in other words, these two you would have to know separately to be able to convert them. If you already know this one, you can convert directly from pound to kilogram. But I usually tell my students that when you're learning these equalities, try to be a little smart and so to see which ones can help you guide to convert from one equality to the other. So this is the sheet that you should know by your first exam. So make sure you write everything down on this page over here, and you get familiar with using them, because I'm more interested in showing you the application, how to use them. I can't really help to open up your brains and dump that in. That's going to be your headache. You will have to sort of start knowing them and memorizing them. Best thing would be probably take index cards and start putting it and looking at it every day to catch a few. Now these equalities are usually present in lots of food products that you see, or a lot of things that you see around the home. So it'll be good for you to know them. Now each equality that I just showed you, remember, equality is a term that's going to represent two different units. It can be in the same system or in two different systems, and it shows a relationship. Now that equality can be converted into what we call as a conversion factor. A conversion factor is actually taking the two equalities and putting it in this format. So inverting it. So where we are writing it as a ratio between, the two units as a numerator and denominator. So I put 1 inch over 2.54 and 2.54 into 1 inch. Now it's important to know that every equality can be expressed in a conversion factor. So for example, if I go back on my feet is 12 inches, and if I have to do my conversion factor, then I can express a foot over 12 inches, or I can say 12 inch over a foot. These would be considered as a conversion factor. Often when we do it in class, I'm going to ask you, what is the equality? Know what I'm asking for. I'm looking for a one-line statement between relationship. If I'm saying what is a conversion factor, then it should be written as a ratio with a numerator and denominator. So let's go on to understand how do we use this equality and conversion factor to solve for a problem-solving technique, which is called as dimensional analysis. So I'm going to give you a little brief explanation of dimensional analysis, and then we will go on to the rest of the slides. So here is dimensional analysis. This is supposed to be an S, okay. A dimensional analysis is a problem-solving technique that relies on the use of a conversion factor to change the measurement from one unit to another. So for example, if I ask you a unit and I say it's 18 feet, and we want to convert our 18 feet into inches. So I want to know X inches, or how many inches is 18 feet. Now we will use the concept of dimensional analysis, in which we will always begin with the given. So my given unit is 18 feet. Always start with first thing is your given unit. And secondly, you should know your plan of attack. And now this is just a one step. So the plan seems to be, we need to know that a foot has, what is the relationship between a feet and an inch? And you can say that a foot has 12 inches. So we know this equality. Now this equality is then converted into a conversion factor. Now in a conversion factor, I have to now be very careful. How do I set this up? Like, as a matter of fact, which is the denominator and which is the numerator? Which goes on the top, what goes on the bottom? The key to that is to look at my given unit. My given unit has feet over here, which means that from the equality, the conversion factor that I will come up should have feet on the bottom. And if that's the case, then I would have 1 foot here and 12 inches on the top. Now, I'm really emphasizing these two units must cancel out. If you do not set it up correctly, you can see that you will have an incorrect answer. So now you would do is take 18 times 12 and come up with your answer. Now when you do your answer over here, we are going to apply significant factor or significant rule. I should actually take the word factor out. We're going to apply the significant rule over here to express our answer. Now here is this value has 2 significant digits and this value has 2 significant digits. So my reported answer should have only 2 significant digits. I hope you got a sense of what we are trying to do here. We are trying to set up a problem setting that I'm trying to show you, where you always begin by writing your giving or starting information, and the next step is to set up the conversion factor so the denominators will cancel the units. And if you can get the denominators to cancel the units, you will have a correct answer. Now the most time I see problems having with students is when they set it up incorrectly. So if this setup is incorrectly set up, if you had it backwards, you can see that you will have a problem with this one. Okay, so this is more like a linear approach, like a one-line statement that I'm showing you over here, and we will expand on this in the coming examples. So let's look at an example over here. A conversion factor may be obtained from a word problem as well. And let's see what is that problem. For example, if we look at the statement that says the price of 1 pound of red pepper is $2.39. Now, there is not an equality given here, but a statement that can be expressed as a conversion factor, because what we're saying is a pound of red pepper, $2.39, or $2.39 over 1 pound. So if, for example, if I have to find out how much would 5 pounds of pepper cost, then my setting should be, I have pounds over here, I should have pounds on the bottom, my denominator should have the same unit so it can cancel, and I should have the dollars on the top, and now all I have to do is multiply 5 with 2.39 to give me my reported answer. And over here, because of significant digits, I have 1 unit here and I have 3 over here. My answer should be reported as 1 significant digit. Another example in which we can use a word statement to obtain a conversion factor is, for example, the cost of the fuel. If the cost of the gallon of gas is $2.34, then you can have these 2 ways of writing it down, in which it depends on whether you're trying to calculate from gallons to dollars or X number of dollars. For example, if I have $50 and I want to know how much gas can I get, then I should have the dollars on the bottom, that is $2.34 over a gallon of gas. And this way, when I set up my denominator to cancel with my given unit, I will be able to come up with my true answer. The multiplication and division is not the tricky part, so I'm not really calculating it for you. The most important part is how to set them up in this manner. So make sure you follow the conversion factor, because this is something that's going to hit you a lot along the way, and I strongly suggest that you catch it up on this first week of this class. So sometimes you can also use, for example, a value that is expressed in percentage to express it in a conversion factor. So for example, if we say 30% by mass fat, what do we mean is that out of 100 gram of the food, 30 grams is fat. So for example, if I give you something that says 20%, let's say we say 20%, let me write it correctly, nicely over here. Let's say we write down 20% glucose. What does that mean? It means that out of 100 ml of water, and as we say this, let me just give you more. 20% of glucose, and this expression is it's an ml. So what it means is that 100 portion of the value, whether it's in milliliters or liters, 20 ml would be glucose. So in other words, the rest 80 is going to be water. So this is pretty much an expression of that can be used for expressing any statement, whether it's a word statement or whether it's an equality. You can express it as a conversion factor. Here is another example in which we can see the thickness of the skin fold at the waist indicates 11% body fat. So we have what percent factors can be written. You can see it's 11 kilogram fat over 100 grams of mass. So you have your values that you're writing down as denominator and numerators, and that is called as a conversion factor. So I think we can stop here, and we will take our next lecture onwards from here.